So welcome to the third tutorial on circles, and this is going to deal with our third objective, which is to write the equation of a circle in standard form and in general form. So this is kind of going to be going backwards. Instead of I give you the equation and you give me a sketch, I'm going to give you a sketch or some important information about the circle, and you write the equation. So if we go to these examples in our notes, notice that the direction for all of the final examples, it says write the general equation of each circle. So let's look at part A. I give you the center and I give you the radius. Well, that's basically just giving you everything that you need to know. Our standard form says x minus h quantity squared plus y minus k quantity squared is equal to r squared. And I've given you everything in this problem. I've given you h, I've given you k, and I've given you r. So all we really need to do is plug these numbers in. So it's going to be x minus 6 quantity squared plus y minus 2 quantity squared is equal to 8 squared. So this is our standard form, though we might say 64, of course, here. I'm not interested in standard form, though I need to put it into standard form before I put it into general form. Now to put it in general form, I need to release all of these parentheses and put all of our terms in the correct order. So I'm going to go ahead and FOIL this x minus 6 quantity squared. Hopefully by now you've seen the pattern. X squared minus 12x plus 36. If you need to write them side by side to FOIL, that's absolutely fine. The y quantity is going to become y squared minus 4y plus 4, and that is all equal to 64. Now let's go ahead and get our like terms together and put our terms in order. So the x squared term comes first, and then the y squared term, and then the linear term, negative 12x, and then the linear y term, negative 4y. I've combined these like terms together to make 40, and that's now equal to 64. One final step, general form is equal to 0. So whatever number is over there, let's get rid of it. In this case, subtraction will do that. So my final answer, x squared plus y squared minus 12x minus 4y minus 24, all equal to 0. So this is our general form given the information in part A. Let's change it up a little bit for part B. This time I'm telling you that the center is the origin. We should all know that the origin is the point 0, 0. So again, I'm basically giving you h and k. But this time, instead of giving you the radius, I'm telling you a point that is that the circle contains. This is a point that is on our circle. So let's talk about that in a minute. If h is 0, x minus 0 squared, quantity squared, would simply be x squared. And if y is 0, k is 0, then y minus 0 quantity squared simply becomes y squared. So we're basically finished with this side of the equation. The question is, what's my radius? Or more importantly, what's my radius squared? So perhaps a picture of our situation might actually help us. I'm going to draw a quick sketch. If you have graph paper and you want to make it more exact, that would be absolutely fine. I'm going to go to negative 5, positive 12. Negative 1, 2, 3, 4, 5, and then 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I go to negative 5, positive 12, that's a point that's on my circle, and of course my center of my circle is right here at 0, 0. So my circle is kind of doing something like this, right? The circle is doing this, and that point negative 5, 12 is on the circle. I can actually see the radius. The radius is this distance from this point to this point. Unfortunately, it's difficult to count the distance of a diagonal line. It's easy to count vertical lines, it's easy to count horizontal lines, but this diagonal distance is more difficult to find unless you see the connection that ultimately we can make a right triangle. And I love Mr. Pythagoras. So if I can make a right triangle, I can use the Pythagorean theorem. I know that the distance of this leg is 5. I don't care if I'm going in the left direction or the right direction. This distance is 5 units. And this distance for this longer leg is 12. So if I'm looking for this missing, and I'm going to call it r, this missing distance, I know the relationship is that r squared is equal to 5 squared plus 12 squared. And since I'm looking for r squared to plug into my formula, or to my general form, then this will be great if I can solve this equation. R squared is equal to 25 plus 144, and R squared is now equal to 169. I do not need to actually figure out what R is, because remember, in my equation is where R squared goes. So 169 is going to go right there. Remember my direction. I do not want my circle in standard form, although it's important to get it to that. I want my equations to be in general form. So it's really just one more step. Subtract this 169 to the other side. Set it equal to 0. X squared plus y squared minus 169 equals 0. There's my general form. A picture sometimes is going to be helpful to find some of the pieces. I've got one more example for you in this tutorial, and here it is, part C. Again, I'm giving you the center, which is just giving away H and K. I kind of need to do that each time. And this time it contains the point 5, 6. So it's very similar to our previous one, except we have a different center. I know that I can go straight into our standard form, at least the left side, since H is 2, x minus 2 quantity squared. Since K is 3, I've got y minus 3 quantity squared. Again, the question is, what is my radius, or my radius squared? I think a picture of this is going to be helpful. I'm going to come over here and I'm going to draw a sketch. I'm going to try and be as exact as I can. If you have graph paper, that's even better. My center is 2, 3. So here's 2, and here's 1, 2, 3. So here's my center. And the point that it contains is 5, 6. So 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. So that point is approximately right there. So again, I've got a picture of what my radius looks like. It's just a difficult distance to count, unless you see the relationship that it does make a right triangle. I'm going to go this way this time and get my horizontal and vertical distances. If I count from this point horizontally, I get 1, 2, 3 units. So that leg must be 3 units long. Once I get there, if I count from here up, I've got 1, 2, 3 units as well. So this distance must be 3. Again, I'm looking for R. And Pythagoras tells us that the radius squared will always be equal to one of the legs squared plus the other leg squared. And I'm looking for R squared, so this is a great equation to solve. I've got R squared equals 9 plus 9, and R squared equals 18. That's the magic number that I needed. I'm going to plug that number right into my equation. There's my 18. And again, remember my directions say for general form. So now we need to unlock our parentheses and get all of our terms together. So we'll do this one last time. So if I FOIL this, I get x squared minus 4x plus 4. Show the work if you need to get to this trinomial. The y quantity turns into y squared minus 6y plus 9. And that's all equal to 18. Now let's get our terms in the correct order. X squared should come first. Y squared should come second. Then our linear x term, then our linear y term. Combine these two numbers together. In this case, that makes 13, and that's all equal to 18. And one final step, set it equal to 0. So I'll subtract my 18, and I've got x squared plus y squared minus 4x minus 6y, and this makes negative 5. So minus 5, all equal to 0. This is our general form for the circle that has this given information. I've got one problem for you to try. So again, at this point, if you could pause this tutorial and work on this try problem, and then unpause if you want to check your answer. Pause right now. Okay, so here is our final answer. Here is our general form. Let me talk you a little bit through this problem. The first thing I did was I realized that they didn't even give us the center or the radius in this problem. So I drew a quick sketch and I plotted the 2 points of my diameter, because I know that the diameter of a circle is 2 times the radius, and the diameter of the circle goes right through the center. So I knew the center was going to be somewhere around here, and I knew that it was going to be exactly in the middle of these 2 points. So I recalled my midpoint formula, which you can memorize your midpoint formula if you want. But basically, all you need to do is understand to add the two x coordinates together and divide by 2, add the two y coordinates together and divide by 2, and we have our center, which is 4, 3. Once I have that, I have h and I have k, so I can write this part of my standard form. Next thing I need to know is what's the radius, or what's the radius squared. So I know that once I know what the center is, which is 4, 3, I know that the radius can be found by making our little right triangle again and understanding that this distance is 3 and this distance is 4. So 3 squared plus 4 squared equals r squared, and here's the work for that. I will eventually come down to r squared equals 25. And I put that into my equation, and then I have my standard form for that circle. General form is going to be foiling this set of parentheses, foiling this set of parentheses, getting all of our terms in the correct order, and of course subtracting this so that it's equal to 0. It's funny this time because it actually cancels out completely, so we actually don't have a constant right here. But here's our final answer. I appreciate your watching this tutorial, and I'll see you in class.